Hey there folks, Mr. G here with another educational video. This is a follow-up, part 2 of solving equations. Last time we solved some problems, we used some algebra tiles, we also used some regular algebra on its own. This time we're going to be using the same techniques, solving some questions that are a little bit harder. Let's start with this one here. So, if you remember, 2 lessons ago we talked a little bit about the distributive property, how we take a number outside of brackets and how we can distribute this in. We're going to be using that in a second, but let's first use this and model it using tiles and see if we can solve it that way. If we have 2 copies of x minus 3, that tells us we should draw out x minus 3 and then do it again. We have 2 copies of this. Once we get here, we actually have 2 different options for how we want to solve this. Some of you might notice that this already lines up really nicely, and we could use the grouping idea that we had last time. If you remember, this is like division. We could actually group this 2 equations. We could actually group this equation into 2 pieces. So this tells us, in order for these 2 sides to be equal, this needs to be equal to this. And we know how to solve these types of equations. We would just move all of our numbers over to the other side. So in this case, we would add 3 of these colored in tiles to both sides, and we would end up with our variable being equal to 5 copies of these positive tiles. In other words, x is equal to 5. Now our other option would be to not group these and just use the same techniques that we used last time to get rid of all of our numbers on this side. So what we could do is just add positive 6, so 6 of these colored in tiles here, and do the same thing on the other side. And we would end up with something like this. Once we get here, now we can see that we can group this really easily. We've got a grouping on the top here and a grouping on the bottom here, both of which say x needs to be equal to 5. So either way you do it, whether you group first and then solve it, or you cancel out these and then group them, you'll get the same answer of x equals 5. We can actually see the same thing happen if we try and solve this without using tiles. We'll see that there are actually 2 different strategies for solving this type of equation. Our first strategy was grouping. So if you'll notice, the first strategy that we had here is grouping the top and the bottom after we drew it all out. And if we remember, grouping is like dividing, so that tells us that one way that we could solve this is taking our equation and dividing both sides by 2. If we have 2 groups of x minus 3 and we divide it into 2 pieces, that tells us those should cancel out. And we should just end up with 1 group of x minus 3. 4 divided by 2 is equal to 2. And from here, we've got a pretty easy equation to solve. We would add 3 to both sides, and we would end up with x equals 5. Our second method, where we cancel these out, that's like us taking this and distributing our 2 all the way in, so that we have all our stuff over here with no brackets. 2 times x would give us 2x, 2 times negative 3 would give us negative 6. And now we can solve this as an equation that we did last time. Very, very similar. We would add 6 to both sides. And then from here we've got 2x equals 10. We would have to divide both sides by 2 to get rid of the 2 in front here. And we would get, at the very end, x equals 5. So like we saw with our tiles, there's actually 2 different ways of solving this: dividing and then getting rid of our numbers on the left side, or distributing out, getting rid of our numbers, and then dividing. Both of these produce the same answer, both of them are good, and it's up to you to decide which technique you'd like to use. Before we go any further though, it's important to check our answers. So here we would have 2, and then we'd substitute in x equals 5, see if this is equal on both sides. We would start inside our brackets for bedmass. 5 minus 3 is 2, and 2 times 2 gives us 4, which is what we have on the right-hand side, so we know we've balanced our equation, we know we got this right. What about an example like this? We haven't seen one quite like this before. All the ones we've seen so far is there was only one place where our variable x showed up. So, just like what we've always done, let's draw this out and see if we can maybe get some information or get some strategies based on our picture. All right, there we go. There's our picture all drawn out. Now, if you remember, one of our key rules, besides doing the same thing on both sides, we want to make sure our variable's on one side and our numbers are on the other side. But now we've got numbers and variables on both sides. What this tells us is that we've got to decide which side all our variables are going to go on, which side all of our numbers are going to go on. And as it turns out, it doesn't actually matter which side you choose. So you'll get different steps, but your answer will be the same, assuming you do everything correct. I know we usually put our variables on the left-hand side, but just to show you that it works just the same the other way, let's plot all our variables on the right-hand side. So that means I would want to get rid of my 2x over here. So I would want to add negative 2x on both sides so I can cancel out all of the x's on my left-hand side. And we would end up with something like this. Now we want to get all of our numbers onto the other side. In this case, that means like we would have to add positive 3 here and positive 3 onto the other side because we're making sure to do the same thing on both sides. And we would end up with something like this. Now we know we can group these. We can group the top and the bottom here. And what that would tell us is that x is equal to 2. So our answer is that x equals 2 here. Now if we wanted to do this with no tiles, again, we have an option of moving all of our variables onto one side or onto the other side. You'll notice here in my first example, we moved all of our variables onto the right-hand side. Got rid of all the stuff on the left-hand side. And so in our final answer, our x was actually on the right-hand side, our number was on the left-hand side, but that's fine. X equals 2 is the same as 2 equals x. To show you that it works the other way, I'm going to do it the other way this time. So in this case, I'm going to take all my variables from the right-hand side, move them over to the left-hand side. So that's like subtracting 4x from both sides of my equation here. 2x minus 4x, so 2 take away 4 would give me negative 2x. These would cancel out. And then I'd have to do the same thing with my numbers. If I've got positive 1 here and I want to move it to the other side, I need to subtract 1 from both sides. Our final step, we've got negative 2x's here. So we would need to divide by this number, negative 2, on both sides of our equation. These would cancel out, leaving us with x. Negative 4 over negative 2 gives us an answer of positive 2. So notice, whether I moved all my variables to one side or the other side, it doesn't matter. As long as I do my steps right, I should still get my answer of x equals 2. As always, it is important to check your answers. So if we want to substitute in x equals 2 into this equation here, we would end up with 2 times 2 plus 1. And is that equal to 4 times 2 minus 3? 2 times 2 is 4 plus 1. This is going to be 8 minus 3. 8 minus 3 is equal to 5. 4 plus 1 is equal to 5. Boom, we got our right answer. For our last two examples here, we're not really able to use tiles very well. There are ways of drawing out these examples, but I find that the tiles are a little bit less helpful in these two particular cases. Let's first start with this example right here. X over 4 equals 9 over 2. Now we've solved similar examples. If we think about last time, we solved something instead of x over 4 equals a fraction, we solved x over 4 equals a number here, and we were able to do that by multiplying both sides by 4. These would cancel out. Again, cross-reducing, we'd end up with x equals 12. Here, we're going to use the exact same technique. Again, we want to get our variable on one side on its own, and then just numbers on the other side. So again, we're going to multiply both sides by 4. But in this case, since this is a fraction, again, it's more helpful to multiply by 4 over 1. Here, our 4's would cancel out, and we would just be left with our variable x. Here, we'd have to do a little bit more complicated cross-reducing, or you could just multiply the tops and the bottoms. 4 times 9 is going to give us 36. 2 times 1 gives us 2. And then we can just divide this. 36 divided by 2 gives us our answer of x equals 18. And as always, let's check. 18 divided by 4, we can reduce this by dividing the top and bottom by 2. That would give us 9 over 2 on both sides of our equation, and we know we got this right. As a side note here, we could also solve this problem using proportional reasoning, and we've actually done this in the past. If you remember, we want to think about what number, we're going from 2 to 4, so what number would we multiply here? We'd multiply by 2, we do the same thing on the top, we would get that x is equal to 18. Just a thought. But you can also use this idea of equation solving that we've talked about to solve these types of proportional reasoning problems as well. Our last example here also features some fractions, but now we have a fraction being multiplied by our x here. So how would we go about solving this? Well, as it turns out, we kind of want to use this same idea, right? In order to get our variable on its own, we got to get rid of this denominator here. So if we wanted to get rid of our denominator here, we would multiply by 2, or in this case, 2 over 1, and we would do the same on the other side. These would cancel out, leaving us just with 3 times x on this side, and then over here, 3 times 2 gives us 6. Finally, we've got 3 copies of x is equal to 6. Another way that we can solve this, we've seen this last time, is we divide both sides by the number out front here to cancel it out. And then finally, we would get our answer of x equals 2. 6 divided by 3 gives us 2. Now we can check our answer, as we always should. If we're multiplying a fraction by a number, it's more helpful to think of this number as that number over 1. And now we could multiply the tops and the bottoms here. We get 6 over 2. 6 divided by 2 gives us 3 on both sides, so we know we got the question right. Alrighty folks, let's check your understanding. 4 questions on the screen here. Grab a piece of paper, pause the video, try these out for yourself, and we'll go over the answers in just a moment. All done? Alright, let's go over the answers then. For the first one here, if you remember, there were 2 different ways that we could solve this. Our first method was to divide first. The second method was to expand first. And by expand, I mean we're going to use our distributive property. If we divide first, that means that we would take this equation right here, and we're going to divide both sides by -3. 2b plus 1, and then negative over negative gives us positive 5. Now we can subtract 1 from both sides. We would get our answer of 2b equals 4. We can divide both sides by 2, and we would get our answer of b equals 2. We could also use the distributive property by expanding this first. So that would mean that we would take our -3 and multiply it into our brackets first here. And we would end up with this. -3 times 2 gives us -6. -3 times 1 gives us -3. And now we would move our number over to the other side. And now we would divide both sides by the number out front of our variable. So we could cancel both those out. And we would also end up with our answer of b equals 2. Now I'm curious how many of you actually checked your answer, because it didn't say to do so here. No matter what, even if it doesn't say to check it, you should always be checking your answer. So let's check this. 2 times 2 gives us 4 plus 1. 4 plus 1 gives us 5. -3 times positive 5 gives us -15 on both sides here, so we know we got our right answer. And notice, no matter which way you do it, if you do it right, you get the right answer. For this one here, again, we want to get rid of our denominator, so that means we're going to multiply both sides by 8, or in this case, what makes more sense is to multiply by 8 over 1, because that will cancel out this denominator here and leave us with just our variable, and this will make multiplying this fraction a little bit easier. 3 times 8 gives us 24, 2 times 1 gives us 2, and then we can just reduce our fraction. We'll get that our variable equals 12. As always, we got to check this. So we would do 12 over 8. Is that the same as 3 over 2? Well, the way we would check this is by reducing this fraction. We could divide the top and bottom by 4 here. And if we do, 12 divided by 4 gives us 3, 8 divided by 4 gives us 2, and we end up with 3 over 2 on both sides, so we know we got it right. For part C here, like what we've seen in the past, there are 2 different ways we can move our variables onto the left and our numbers onto the right, or the numbers onto the left and the variables onto the right. Either way you do this, you'll get the right answer. In this case, let's move the variables onto the left-hand side. In our first example, we did moving them onto the right-hand side, so let's move it onto the left. So that means I want to get rid of this 2y, this -2y here. So I would add 2y to both sides. That would give me 8y minus 3 is equal to 13. Now we want to move our numbers onto the other side. In this case, we would add 3 to both sides. And then finally, we just have to divide by the number in front of our variable. If we've got 8 copies of y is equal to 16, we divide these 8 copies so that we only have 1 copy left. And this would give us that our answer is 2. And don't forget to check. 6 times 2 minus 3, is that the same as -2 times 2 plus 13? This is going to be 12 minus 3. This would be -4 plus 13. 12 minus 3 gives us 9. -4 plus 13 also gives us 9. So we know we got the right answer. Finally, for this one here, We've got this fraction here, but now we've got an extra complication because we've got this positive 4 next to it. But just like any other example, we ought to get all of our numbers onto one side, all our variables on the other. So here we're going to start by subtracting 4 from both sides to get rid of this. Negative 8 minus 4 gives us negative 12. Now we want to get rid of our denominator here, so we would multiply both sides by 5, or 5 over 1, whichever is easier, whether we're dealing with fractions or not. Here, our numerator of this, so this 5 and this 5 would cancel out. From cross-reducing, we would be left with 3z is equal to negative 60. And then we divide both sides of our equation by 3. We'd end up with z is equal to negative 20. Finally, one last check. Let's make sure we got it right. So in this case, when we're multiplying a fraction by a number, we do it over 1. So this would be like negative 60 over 5. Negative 60 over 5, that's like negative 60 divided by 5, which is negative 12. Negative 12 plus 4, that gives us negative 8 on both sides, and we know we got the question right. Thanks for tuning in, folks. Please make sure you check Teams for all of the daily homework, assignments, and other announcements, and I will see you all in the next video.